For Lab 3, we looked at the orbit of a planet around a black hole. So for this lab, we were trying to use the relationship between change in momentum and net force to determine the mass of a black hole. And to do this, we broke down the net force, which in this case was only the force of gravity, into parallel and perpendicular components and modeled that in Python. And at the end, I found my black hole's mass to be 2.49 times 10 to the 31st kilograms. So given from WebAssign, we know the mass of the star, the position of the star over time, and the black hole's position. And using that information, we can use fundamental principles to analyze its motion and get data to give us the mass of the black hole. So using the law of gravitation right here, and we know that gravity is the only force acting on this object, so we can also break that down into its momentum components and use that to figure out its mass at the end of the calculation. The Python code pulls a Excel script that contained position data of the star over a period of time, and then we used that in our Python code in a while loop to update the position and get a velocity vector, which we then use to calculate the net force and change in momentum. So here is my model. As you can see, the black arrow represents parallel component of net force, the blue arrow represents the perpendicular component, and the yellow arrow is the net force vector. The major differences between the parallel and perpendicular components is that the parallel component of net force changes the speed and is equal to the parallel component of the rate of change in momentum over time, and the perpendicular component of net force changes the direction and is equal to the change in momentum over time for the perpendicular component. It's also important to note that the momentum change is a result of the net force and not the other way around, so that the net force is what causes the momentum to change. To answer the what if question seen here, no, you could not tell the difference between the black holes. The black hole would have to have to have the same mass in order to exert the same influence on the star's motion as before. According to the law of gravitation, F net is proportional to both masses involved, so changing only one would change the value of F net, which would change the star's motion as a consequence. My overall conclusion from this experiment was that my model was successful in predicting the mass of the black hole using the formula seen here and the information gathered from the Python iteration. And that pretty much concludes my lab presentation.